Hello friends, myself Dattatreya Jadhav. I am from HM College Karad. In our previous video, we see some special types of integrals. Here is integration of 1 upon a square plus x square dx is equal to 1 upon a into tan inverse of x upon a. Second formula is integration of 1 upon a square minus x square dx is equal to 1 upon 2a into log of mod of a plus x divided by a minus x plus constant of integration c. Here third formula is integration of 1 upon x square minus a square dx is equal to 1 upon 2a log of mod of its x minus a divided by x plus a plus constant of integration c. Fourth formula is integration of 1 upon square root of a square minus x square dx is equal to its sine inverse x upon a plus c. Fifth formula is integration of 1 upon square root of a square plus x square dx is equal to log of mod of x plus the denominator plus c, that is square root of a square plus x square plus c. Sixth formula is integration of 1 upon square root of x square minus a square dx is equal to log of mod of x plus denominator, that is square root of x square minus a square plus constant of integration c. We see here in first three formulas there is no sign of root. Okay, in all the formulas numerator contains 1. In all the formulas numerator contains 1, and in first three formulas there is no square root. Okay, so such a type of integration started with solution answer of this integration started with the term 1 upon a, 1 upon 2a, 1 upon 2a. While here in exam formula 4, 5 and 6 there is no term like 1 upon a, 1 upon 2a. Okay, so look at here, in all integrals there is in numerator 1 and in our denominator contains two terms. Okay, first one is a square and second one is x square. Okay, and signs are changes here. Okay, and some formulas of square root and some formulas without the square root. Okay, so look at here. Here a square plus x square cannot be factorized, so formula is 1 upon a. Only one factor is there, so formula is 1 upon a into tan inverse of x upon a. Remember that. Okay, here a square minus x square is factorized, a minus x into a plus x. So two factors are there. Formula started with 1 upon 2a. Okay, into log of mod. Yes, two factors are a minus x and a plus x. Since it is started with constant, a is constant, so write positive factor in numerator and negative factor in denominator, that is a plus x in numerator, a minus x in denominator. In third formula, okay, here x square minus a square can be factorized in two terms, that's x minus a and x plus a. Okay, so two factors are there, so starting with 1 upon 2a into log of mod of. Okay, two factors are x minus a and x plus a. Since it is started with x variable term, so write this minus factor in numerator, that is x minus a divided by x plus a plus constant of integration c. In fourth formula, integration of 1 upon square root of a square minus x square dx. Okay, integration of 1 upon square root a square minus x square dx. Remember, a square plus x square is in denominator, the formula is 1 upon a tan inverse. Okay, and here remember, in denominator there is square root sign, and inside the square root sign there is term a square minus x square. Here remember a square plus x square, and here remember a square minus x square dx. So formula is sine inverse x upon a plus c. And fifth and sixth formulas are very simple. Here integration of 1 upon square root of a square plus x square dx is equal to, starting with log of mod of, first term is x plus second term is denominator. Okay, root of a square plus x square plus c. And sixth formula, 1 upon integration of 1 upon square root of x square minus x square dx is equal to log of mod of x, first term is x plus second term is denominator, square root of x square minus a square plus c. Okay, so in this video we solve some examples on special integrals. Okay, so starting with some simple examples for learning the formulas or understanding the formulas. First example is evaluate integration 1 upon x square plus 9 dx. Okay, first look at here. In numerator there is term 1, in denominator there is a variable square, and in second term of denominator that is constant. Remember, the type is used when there is in numerator 1 and in denominator 1 is a variable square and second one is constant square. Then and then we use these types of formulas, that is special integral formulas. First, denote the given integration by I. So starting with, let I is equal to integration of 1 upon x square plus 9 dx. Okay, we know that, yes, here is the first term x square. X square is the square of x, so I can write this as x square plus 9 is square of 3, so I can write this as 3 square dx. Why we write 9 as a 3 square? Because in all these formula, one is a variable square and second is a constant square. Okay, so I can write this as 3 square. So it becomes integration of 1 upon x square plus 3 square dx. It's a variable, it's a x square, and here is 3 is constant, it's a x square. Okay, so integration of 1 upon is x square plus a square. Here is that formula. Integration of 1 upon a square plus x square dx is 1 upon a tan inverse of x upon a. But what is the value of a? Here value of a is 3. So 1 upon 3 into tan inverse of x divided by 3 plus constant of integration c. Okay, it's the final answer of the given question. Okay, it's very simple. Look at here in second example. Evaluate the integration 1 upon, yes, evaluate integration 1 upon x square minus 9 dx. Evaluate integration 1 upon x square minus 9 dx. First, it is an example on integration. So denoting that integration by I, let I is equal to integration of 1 upon x square minus 9 dx, which is equal to integration of, in numerator there is term 1, in denominator first term is a variable square, so I can write second term, that is constant term, as a variable constant square. 9 is a square of 3, so I can write this as x square minus 3 square dx. Okay, look at here, x is a variable in denominator, x is a variable, it's x square, and yes, 3 square is a constant, 3 is a constant, so it's a square, and formula looks like integration of 1 upon x square minus a square. Here is that formula. If first term is variable square, then formula is 1 upon 2 into log of mod of x minus a divided by x plus a. Write negative factor in numerator and positive factor in denominator. Okay, here factors which is equal to 1 upon 2a, 1 upon 2 into value of a is 3, so 1 upon 2 into 3 into log of mod of the factors of x square minus a square is x minus a and x plus a. The factors of x square minus 3 squares are x minus a and x plus 3. Since the formula is started with variable, so write negative factor x minus 3 divided by x plus 3 plus constant of integration c. 1 upon 2 into 3 is 1 upon 6 into log of mod of it's x minus 3 divided by x plus 3 plus constant of integration c. Okay, let's see another example. Evaluate integration 1 upon x 9 minus x square dx. First, it is an example on integration. So denote that integration by I, let I is equal to We know that 9 is the square of 3. Here in numerator there is a 1 and in denominator there is 1 variable square. Write another term as a constant square. So 3 square is 9. So 9 can be written as 3 square minus x square dx. Okay. So integration becomes integration of 1 upon 3 square minus x square dx. 3 is the constant, so it looks like a square and x is variable as it is, and we know the formula of integration of 1 upon a square minus x square dx. Integration of 1 upon a square minus x square dx is equal to, there are two factors of a square minus x square, that a minus x and a plus x. So starting with 1 upon 2a into log of mod of, write positive factor in numerator because here formula started with constant square. Okay, so write positive factor, that is a plus x in numerator and a minus x in denominator plus constant of integration c. So integration becomes I is equal to 1 upon 2 into a, that is 3 into log of mod. Tell me the factors of a square minus x square. It's a minus x and a plus x. Factors of 3 square minus x square, 3 minus x and 3 plus x. Since formula is started with 3, that is constant, so I can write positive factor first. Positive factor is 3 plus x divided by negative factor 3 minus x plus constant of integration c. After simplification, we can say that 1 upon 2 into 3 is 6. So integration, value of that integration is 1 upon 6 in log mod 3 plus x divided by 3 minus x plus constant of integration c. Okay. Now next example is evaluate integration. Now next example is evaluate integration of square root of 1 upon evaluate integration of 1 upon square root of 9 minus x square dx. Okay, first denote the given integration by I. So let I is equal to integration of 1 upon square root of 9 minus x square. Okay, here numerator is 1 and denominator contains square root sign. Okay, so we use one of the formula from these. Okay, now in denominator there is one variable square, so write another term as a constant square. So I can write this as 1 upon square root of 9 is the square of 3 square minus x square dx. Okay, here we know 3 is a constant, consider it as a square minus x as a variable, so x square, and it looks like in denominator root of a square minus x square. And here is the formula, integration of 1 upon square root of a square minus x square dx is equal to sine inverse x upon a plus c. So I can write this as solution of the integration is sine inverse value of x is x upon a is 3 plus constant of integration c. It's our final answer. Okay. Now second example is evaluate integration 1 upon square root of x square minus 9 dx. Okay, evaluate integration of 1 upon x square minus 9 dx. First, it is an example of integration, so we denote that integration by I. Let I is equal to. Okay, in numerator there is 1. Okay, in denominator here in square root 1 is variable square. So I can write second term as a constant square. 9 is the square of 3. So I can write this as 3 square dx. Okay, which is equal to. Now here is term x. So it's x square. For 3, that is constant, we use a. It's a square, and it looks like square root of x square minus a square. Such a type of integrations are solved by the formula integration of 1 upon square root of x square minus a square dx is equal to log of mod of x plus denominator term plus. Okay, so answer of the given question is log of mod of x starting with x plus denominator. In denominator there is x square minus 3 square plus constant of integration c, which is equal to log of mod of x plus square root of x square as it is minus c square is 9 plus c. Okay, it's our fifth example. Next example is evaluate the integration. Evaluate integration 1 upon square root of x square plus 9 dx. 1 upon square root of x square plus 9 dx. Okay, look at here. In this example also numerator is 1. In this example numerator is 1 and denominator contains square root sign in which 1 is a variable square. So I can write second term is also as a constant square. Okay, so integration becomes I is equal to integration 1 upon square root of x square plus 3 square dx. Okay, here is the x term, so I can write this as x square. Here is 3 square, I can write this as a square, and middle sign is plus, and it is in square root. So it looks like one integration of 1 upon square root of x square plus a square. That is our fifth formula. And we know that integration of 1 upon square root of a square plus x square dx is equal to log of mod of x plus a denominator plus constant of integration c. So answer of the question is log of mod of x plus denominator term is square root of x square plus 3 square plus constant of integration c. After simplification, we write this as log of mod of x plus square root of x square plus 9 plus constant of integration c. Similarly, you solve the above 6 examples. Replace 9 by 4, 16, 25. Okay, replace that constant in the above examples by 4, 16, 25 for practice of these formulas. Okay, now moving to our next example. Evaluate integration. Evaluate integration 1 upon 2x square plus 7. 1 upon 2x square plus 7 dx. Look at it. Here in this example contains variable terms, not sine, cos, tan. So it is example of algebraic integration. First, denote the given integration by I. Let I is equal. Here numerator contains 1. Okay, here numerator contains 1 in all such cases, and denominator contains one term of variable square. Okay, but in all the formulas, coefficient of x square is unity. In all the formulas of special integrals, coefficient of x square is unity. So first make coefficient of x square is 1. After taking 2 common from denominator, that is taking 1 upon 2 common from integral side, we write this as 1 upon x square plus 7 by 2 dx. Okay, taking 2 common, 2 into x square, 2 common, it's x square. From 7 there is no, we can't take common 2, so divided by 2. Okay, so which is equal to 1 upon 2 into numerator contains 1, denominator contains 1 variable square, one term of variable square. Write the second term as constant square. Tell me 7 by 2 is a square of which term? 7 by 2 is square of root 7 divided by root 2. Okay, so I can write this as 7 by 2 as root 7 divided by root 2 bracket square. Here is the term of variable, so you consider that as x square. Here is the, yes, root 7 by 2 is root 7 by 2 or root 7 divided by root 2. Okay, here are constants, so I can write this as a square. Okay, and formula is 1 upon x square plus a square. Okay, so formula is integration of 1 upon a square plus x square dx is equal to 1 upon a tan inverse of x upon a. Okay, so integration becomes I is equal to 1 upon 2 into 1 upon a. What is the value of a? Root 7 divided by root 2 into tan inverse x. What is the value of x? It's x divided by a. A is what? Root 7 divided by root 2 plus constant of integrations. Okay, 2 can be factorized as root 2 into root 2. 1 root 2 get cancelled. Root 2 into root 7. Root m into root n. Root m. Root 2 into root 7. Root 14. So answer of the integration is 1 upon root 14 into tan inverse of root 2x divided by root 7 plus c. Okay, or we can use another method for solving the given integration as, okay, look at here, numerator contains 1 and denominator contains 1 variable square term. Okay, so we write this as 1 upon, write denominator's first term in complete square of variable. So I can write this as root 2 into x bracket square. Okay, 2 is square of root 2. So I can write this as root 2 into x bracket square plus second term can be written as in the form of square. It's the root 7 bracket square dx. Okay, here is the x square plus the term is constant, so I can write this as a square. Here is the term of x, so I can consider that x square plus a square. And we know that integration of 1 upon x square plus a square is 1 upon a into tan inverse of x upon a. So 1 upon a, what is the value of a? Is root 7, okay, into tan inverse x upon a. What is x? Root 2x divided by a, that is root 7 plus constant of integration c. Don't write directly plus constant of integration c. Why? To get the answers of both the integration are now different. Why? Because here coefficient of x is root 2 and we know that if integration of f of x dx is equal to g of x plus c, then integration of f of linear equation, that is ax plus b dx, is equal to g of ax plus b divided by a plus c. Okay, so divide by coefficient of x, that is I can multiply here by coefficient of x, that is 2 root 2. So multiplying by 1 upon root 2. After simplification, it becomes root 7 into root 2 root 14 into tan inverse of root 2x divided by root 7 plus. Now look at these two answers of same integration. Answers are same. Okay, so you can use any one of these methods to evaluate such a type of integrals. Okay, next example is evaluate the integration. Evaluate integration 1 upon 4x square minus 3 dx. 1 upon 4x square minus 3 dx. Okay, so first denote the given integration by I. Let I is equal to, here in numerator there is term 1, okay, and in denominator there is term of square of a variable. Okay, so formula is I think that example is on special integrals, so I can solve this and taking making coefficient of x square is unity. So taking common 4 from denominator and taking common 1 upon 4 from integral side, we write this as I is equal to 1 upon x square minus 3 divided by 4 dx. Okay, which is equal to 1 upon 4 as it is into integration of 1 upon, here is term x square minus, I can write root 3 by 4 as root 3 square of the term, that is root 3 divided by 2 bracket square. Okay, look at here is one variable square and here is the term of constant square. I can write this as a square, and from it looks like integration of 1 upon x square minus x square. The factors of x square minus x square are 2. So formula start with 1 upon 2a. So answer is 1 upon 4 into 1 upon 2 into a. What is the value of a? Root 3 divided by 2 into, yes, log of mod. Right, since it is started with variable square, right, for negative factor in numerator x minus a, that is x minus root 3 divided by 2, negative factor. And what is the positive factor? X plus root 3 divided by 2 plus constant of integration c. 2 get cancelled, it's 1 upon 4 root 3 into 1 upon 4 root 3 into log of mod. After simplification, 2 making denominator same in numerator and denominator, 2x minus root 3 divided by 2, 2x plus root 3 divided by 2, 2 get cancelled. So I can write directly as 2x minus root 3 divided by 2x plus root 3 plus constant of integration c. It's our another example. Okay, next example is evaluate integration 1 upon 25 minus 9x square. Evaluate integration 1 upon 25 minus 9x square. Okay, first denote the given integration by I. So starting in solution, let I is equal to integration of 1 upon 25 minus 9x square. Now look at here, coefficient of x square is 9, so I can take common 9 from denominator, and from integration I can take common 1 upon 9. So integration becomes I is equal to 1 upon 9 into integration of 1 upon, when we take common 9 from 25, we write it's 25 divided by 9 minus x square dx, taking common 9 from denominator. Now 1 upon 9 as it is into integration of, here is one term of variable square, I can write this as a constant square. 25 is square of 5 and 9 is square of 3, so I can write this as 5 by 3 square minus x square dx. Now it looks like a square minus x square. Here is the constant term, so I can write this as a square minus x square. How many factors are there? There are 2 factors of a square minus x square. So formula started with 1 upon 2 into a. What is a? It's 5 by 3. Okay? 1 upon 2 into a into log of mod. Since formula is started with constant square, so write positive factor in numerator, that is a plus x, that is 5 by 3 plus x, positive factor of that term is divided by negative factor 5 by 3 minus x plus constant of integration c. After simplification, 3 3s are 9, 5 2s are 10 into 3 is nothing but 1 upon 30 into log of mod of 5 plus 3x. Okay, divided by 3. 5 minus 3x divided by 3. 3 get cancelled. 5 plus 3x divided by 5 minus 3x plus constant of integration c. Here is the answer of the given question. Okay. Now take another example. Evaluate integration of 1 upon square root of. Evaluate integration 1 upon square root of 3x square plus 8. Okay, dx. Look at here. First I denote the given integration by I. So starting solution with let I is equal to integration of 1 upon square root of 3x square plus 8. Here numerator is 1 and denominator contains root sign. That means we use one of the formula from special integrals, that is 4, 5, 6. Okay, and there is a term of one term in square root is variable square. Okay, so conformably we use special integral formulas here. Okay, first make coefficient of x square is 1 because in all formulas here coefficient of x square is unity. Here coefficient of x square in each case is unity. So I can take 3 common in square root. So its integration becomes I is equal to integration of 1 upon square root of 3 into x square plus 8 divided by 3. Okay, dx. We know that root of m into n is root of m into n is root m into root n. So it becomes root 3 into root of x square plus 8 by 3. Root 3 is constant, take outside the sign of integration and it becomes integration of 1 upon x square plus 8 by 3 dx, which is equal to 1 upon root 3 as it is into integration of 1 upon, here is first term is variable square, square root is there. Here in denominator square root of x square plus, right, second term as a square of the term. Root 8 is square of 2 root 2 and 3 is square of root 3. So I can write this as 2 root 2 divided by root 3 bracket square. Okay, 1 upon root 3 as it is into, it looks like one term is variable square and another term is constant square and denominator is in root. So we use here integration of 1 upon root of a square plus x square log of mod of x plus denominator. So log of mod of x, x is what? X plus a denominator term. Denominator term is square root of x square plus 2 root 2 divided by root 3 bracket square plus constant of integration c. After simplification we write this as 1 upon root 3 into log of mod of x plus square root x square plus square of 2 root 2 is clearly 8 and square root of root 3 is 3 plus constant of integration c. Here is the answer of the given question. 1 upon root 3 into log of mod of x plus square root of x square plus 8 divided by 3. Now, moving to our next example, evaluate integration 1 upon root of 2x square minus 5 dx. Evaluate integration 1 upon square root of 2x square minus 5 dx. Okay. Look at here, numerator is 1, in denominator there is a variable square. So, it is clearly example on special integrals. So I can write here, first denote the given integration by I, so that I is equal to integration of 1 upon square root of 2x square minus 5 dx. Okay. Make first step is what? Make coefficient of x square is unity. So taking 2 common in denominator, in square root, so integration becomes integration of 1 upon square root of 2 into x square minus taking 2 common from 5, we write 5 by 2 dx. Okay. Now we know that root m into n is root m into root n. So root 2 into root of x square minus 5. Root 2 is constant. take outside the sign of integration. So integration becomes I is equal to 1 upon root 2 into 1 upon, yes, square root of x square minus 5 by 2. X square minus 5 by 2 square root of x square minus 5 by 2 dx, okay, which is equal to 1 upon root 2 as it is. Now here is in denominator, first term is square of variable, I can write second term as a constant square, okay. 5 is square of root 5, 2 is square of root 2, so I can write this as root 5 divided by root 2 bracket square. 5 by 2 as root 5 divided by root 2 bracket square dx, okay. Now in denominator it looks like square root of x square minus a square, and we know that formula for integration of 1 upon square root of x square minus a square is log of mod of x plus denominator. So log of mod of 1 upon root 2 as it is into log of mod of x, what is x? X as it is, plus denominator term is x square minus root 5 divided by root 2 bracket square plus constant of integration c, 1 upon root 2 constant as it is into log of mod of x as it is plus square root of x square minus root 5 divided by root 2 bracket square is 5 by x square minus 5 by 2 plus constant of integration c. It is our final answer, okay. 1 upon root 2 into log of mod of x square, log of mod of x plus square root of x square minus 5 by 2, okay. Now moving to our next example, evaluate integration. Evaluate integration. 1 upon square root of 11 minus 4x square dx. Okay, now look at here. In numerator there is 1 and denominator contains square root sign, in which one term is square of a variable. So make coefficient of x square is 1. So taking 4 common inside the square root, integration becomes integration 1 upon square root of, taking 4 common, it's 11 by 4 into 11 by 4 minus x square dx, okay. So we know that square root of 4 is 2, 2 is constant, take outside the integration sign, it becomes, so integration becomes 1 upon 2 into integration of 1 upon square root of 11 by 4 minus x square dx. In denominator there is one term which is square of variable, so I can write first term as a square of, yes, constant. 11 is square of, yes, root 11, and 4 is square of 2, so I can write this as 11 upon 4 as root of 11 divided by 2 bracket square minus x square dx. It looks like constant square minus x square, and it is in square root, okay. It is looks like integration of 1 upon square root of a square minus x square dx. The answer of the integration is sine inverse x upon a, which is equal to 1 upon 2 constant as it is into sine inverse. What is the value of x? It's x divided by, what is the value of a? Root 11 divided by 2 plus constant of integration. After simplification, I can write this as 1 upon 2 into sine inverse. Look at here, denominator comes in numerator, 2x divided by root 11 plus constant of integration c. 1 upon 2 sine inverse, 2x divided by root 11 plus constant of integration c. Here is the last example, okay. In today's lecture, evaluate integration. Evaluate integration. Square root of 9 plus x divided by 9 minus x dx. Okay. Look at here. Square root of 9 plus x divided by 9 minus x dx. I can simplify first denote the given integration by I. Let I is equal to integration of square root of 9 plus 6 divided by 9 minus 6 dx. Now separating square root sign, it's root of 9 plus 6. Integration of root of 9 plus 6 divided by root of 9 minus x dx. Okay. On multiplying numerator and denominator by, yes, conjugate of denominator means conjugate of 9 minus 6, square root of 9 minus 6 is square root of 9 plus x divided by square root of 9 plus x dx. Okay, make simplification here. Okay, now we know that the formula is a into a is nothing but a square. Okay, a into a is nothing but a square, and a minus root m into root m is the root mn, and last formula is a minus b into a plus b is equal to a minus a square minus b square. Okay, so using these formulas, root 9 plus x into root 9 plus x, we get 9 plus x divided by root of 9 minus x into 9 root of 9 plus x. It's root of 9 minus x into 9 plus x. Okay. So integration becomes I is equal to integration of 9 plus x divided by root of 9 minus x into root of 9 plus x dx, which is equal to integration 9 plus x divided by. Now look at here, it looks like a minus b into a plus b. It's a square minus b square, a square minus b square. Square of the first term, that is 9 square minus, okay, x squared dx. Now to solve this integration, I can separate the denominator. So integration becomes integration of, yes, on separating denominator to numerator, integration of 9 divided by square root of 9 square minus x square, means variable square, constant square minus variable square. Okay, plus x divided by square root of 9 square minus x square. So it is example on, yes, some special integrals. Now inside the integration there is addition. We separate integration sign. So integration of 9, it becomes integration of 9 divided by square root of 9 square minus x square dx plus integration of x divided by square root of 9 square minus x square dx. Okay, here 9 is constant, take outside the integration, and inside the integration there is some 1 upon root of 9 square minus x square dx. Okay, now I adjust derivative of denominator. Remember that step. I can adjust derivative of denominator in numerator. In denominator there is some root of 9 square minus x square, and derivative of the function which is in square root is 9 square is 81, constant, that is derivative of constant is 0 minus derivative of x square is 2x. So adjusting the term minus 2x, but there is plus x, so I can write this as minus minus plus x. Okay, here 2 is extra. For equality, maintaining equality, we divide by 2. Here we multiply by minus 2 and divide by minus 2 dx. Why we adjust such a adjustment? So I can write here that adjustment. We know the corollary, integration of f dash of x divided by square root of f of x dx is equal to 2 root f of x plus c. It's a corollary on substitution. If in our integration denominator is in square root and the term in square roots whose derivative is in numerator, then we write 2 root f of x, 2 into denominator plus. Such type of integrations can be solved by that corollary. So answer is 9 into, integration's answer is 9 into, yes, it looks like 1 upon a square minus x square. So formula is 1 upon root of a square minus x square. Here is the formula, sine inverse x upon a, sine inverse. What is x? X is x, and what is a 9? Sine inverse x upon 9 minus 1 upon 2 constant into. Yes, we use this corollary is here. Integration of f dash of x divided by square root of f of x 2 into root of f of x. Okay, 2 into root of 9 square minus x square plus c, which is equal to 9 into sine inverse x divided by 9. 2 get cancelled, minus root of 9 square is 81 minus x square plus constant of integration c. Solve a similar example by replacing 9 and 2, 4. Okay. I hope you understand all these examples on special integrals. Okay. So thank you.